Welcome to Grade 12 Advanced Mathematics, Unit 5 Integration, 5.5 The Fundamental Theorem of Calculus, Part 2. In this video, we will learn how to find velocity and position functions using the Fundamental Theorem of Calculus. Also, how to write the equation of a tangent line at a given point to a function. Welcome to Hasna Spot Math. Let's spark our math skills together. So let's continue computing the distance fallen by an object. Here if you notice, the downward velocity of a skydiver is given by a function 9 times 1 minus e power negative t meter per second. For the first 5 seconds of a jump, you are asked to compute the distance fallen. How to find this? So simple. Antiderivative 0 to 5 interval. That time you will be finding out the antiderivative of the given function, the lower limit 0 and the upper limit 5. You can use the calculator or else you can proceed finding antiderivative manually. We are opening the bracket, so we get 9 times 1 and 9 times e power negative t. 9 dt is nothing but 90 minus 9 e power negative t will be getting as e power negative t and also a negative sign outside there. So when you are finding the antiderivatives and then proceed with substituting upper limit and the lower limit. Now here we go with answer 36 meters. If you prefer, you can even directly enter this function in the calculator. You will get 36 meters. The equation of a tangent line. Look at this question. Net rate of change of water is given. When net rate of change of water is given, you should understand something. This is the antiderivative of the water because rate of change is given. Now let's proceed with the part A. They asked to determine when the water level is increasing and when the water level is decreasing. So first let's focus on part A. And the interval given is 0 to 3. So here we go. W prime is given because you know rate of change of water is given. That means W prime. We notify that function as f of t. Now to find whether the water level is increasing or decreasing, first you need a critical number. Let's equate it to 0. When we equate it to 0, we'll get two values for t as t square is a quadratic equation. We'll get negative 1 and positive 1. As time cannot be negative, we cancel the negative 1. Let's move with only the positive 1. Now let's find the number line. 0 to 3, already the interval is given as 0 to 3. So 0 to 3 and in between we will include the critical number 1. And let's find any number between 0 and 1. Let it be half, and 1 and 3. Let it be any number. Let it be 2. When we substitute it in the first derivative, we'll get the first half negative and second half positive. So it's decreasing in the first half and increasing in the second half. So the decreasing interval is from 0 to 1 and the increasing interval is from 1 to 3. Here we go with the second question. W of 0 is given as 200 liters. W prime is also given. What is W of 3? How to find W of 3? Let's integrate both the sides of W prime t is equal to 20 times t square minus 1 from 0 to 3, where integral W prime is nothing but W of t dt. And so you get this expression. Now let's replace by the upper limit and then the lower limit. W of 3 is what you need and W of 0 is given as 200. So when you simplify, you will get your expression like this, and when you transpose your 200 to the other side, negative become positive and you will get your W of 3 as 320 liters. So at 3 minutes, you get 320 liters. Now let's enter to the last question of this short topic. For the given function, let's find the equation of tangent line at x is equal to 2. You all should remember what is the equation of a tangent line. Exactly. Y minus y1 is equal to slope, which is m times x minus x1. Let's find each terms. x1 is already known as 2. You can replace it in your y function. You will get y1, and when you derivate the given antiderivative, you will be getting the slope. Let's find one by one. First, let's use the fundamental theorem of calculus part 2 to find the derivative, which will be your slope later. So first let us derivate x square, which is your 2x, and then replace your x square in the place of t. That's how you got ln x square the whole power 3 plus 4. Now let's replace our x by the given x, which is 2. So when you're substituting 2, you'll get your answer as 4 ln 68, which is nothing but 16.878. Now let's find our points y, f of 2. So let's replace our x in the upper limit with 2 to get y. You should note that this is also 4 and the upper limit 2 square will also be 4. If your lower limit and the upper limit are same, you will get your answer as 0. Now let's substitute in our equation of a tangent line. You have your y0, which is 0, and you have your m, which is 16.878 of 4 ln 68, and you all know your x0, which is given in the question, that's 2. So your expression is 4 ln 68 times x minus 2. That's all for today. Keep revising, keep practicing. If you have any queries, please don't forget to comment below. Subscribe and share with your friends. Bye-bye.